Hi, my name is Megan Zodi and I am in Lab Section 2 of Organic Chemistry. This video shows the analysis of an unknown compound using NMR spectroscopy. The experimental methods used to identify this unknown compound starts by preparing a sample in an NMR tube, which is then placed into the instrument. By using a Pasteur pipette, equal volumes of unknown liquid to the solvent chloroform D were placed into the tube along with a drop or two of tetramethylsilane. TMS is used as a reference point that is set at 0 ppm. After these are added, the NMR tube is capped and shaken lightly to mix the sample together to get it ready for NMR analysis. A collar is placed around the tube and the tube is decontaminated using a chem wipe. The tube is then placed within the instrument to obtain the peaks and corresponding NMR values. The NMR spectra depicts a distinct peak at 3.791 ppm. This falls within the range of 3 to 4 ppm, indicating there is an electronegative atom adjacent. There is a set of peaks approximately at 7.332 ppm. This means there is an aromatic ring present. Another set of peaks at 7.958 ppm, also indicating an aromatic ring. The set of peaks at 7.332 ppm and 7.958 ppm indicate an aromatic ring, limiting the unknowns down to acetophenone, methylbenzoate, M-xylene, and propylbenzene. The peak present at 3.791 ppm shows there is an electronegative atom. This narrows the unknown spectra down to methylbenzoate. The spectra is not acetophenone because there is no peak present around 2.1 ppm, which would indicate a hydrogen next to a carbonyl group. The integration values for the spectra were multiplied by 2 to get them to a whole number. These values show how many hydrogens are present on that type of carbon. The integration values on this peak, integration value on the peak at 3.791 ppm is an indication that the carbon adjacent to the electronegative atom has 3 hydrogens, which is present in methylbenzoate. The integration values on the aromatic ring are 3 and 2, and both have a splitting pattern of a multiplet, meaning there are neighboring carbons with hydrogens. The peak present at 3.791 ppm is a singlet, showing there are no neighboring carbons with hydrogens. After viewing all of this information, the unknown can be narrowed down to methylbenzoate.